First of all, I would like to, before I discuss the agenda, I'll talk a little bit about myself, right? So, my name is Mukul Gaur, and I'm presently working in EXL as a, solution architect, right, at a AVP level. And yes, I have 15 plus experience. I'm a science graduate. I have done my post graduation in computer science, and I have done. I've started my career from performance testing and automation testing in various tools and technologies. And this is like seventh year in Excel. And if I talk about the tools that I've worked on, they are like from UFT to QTP, from a load runner, and just few protocols on load runner and on Selenium. But presently, if I talk, my present role is to design the solution and framework for test automation, and working on Python at the moment, and Test Complete, which is a smart beers tool, and giving my you know insights to the automation world in EXL, in testing center of excellence as well. So that's about me. And today's agenda, let me share my screen. So as Pratibha mentioned, that today we'll be talking on the trending technologies in software testing. So today I'll be talking and giving my views on software testing. We'll talk a little bit about what is QA, what is software testing, why do we do, what are its benefits and all, and what are the benefits of test automation. Then I'll touch upon hyper test automation, which is a buzzword these days, right? And it's very much in the trend. I'll also talk about the Agile and DevOps, and the codeless test automation, quality engineering, and quality at speed. I'll touch upon the intelligent automation using artificial intelligence and machine learning, and also the testing of the headless applications, what we call as APIs and web services test automation. And also I'll try to touch on the cloud-based testing. I know that 2 hours is very less for all these big topics, but because the wider topic is uh, trending technologies in software testing, which includes all these, right? I know in one topic itself takes a couple of days to cover, at least to have a good insight, but I'll try to give you some insights on these topics, right? Be it agile, DevOps, be it quality engineering and all. So let's start. Let me come in this mode, which is screen sharing mode. All right, guys, let's have a look at this. So if I go with these events that has happened in the past, right, you can see that in April 2015, a Bloomberg terminal in London. So if I go by these events that have happened in the past, like Bloomberg terminal in London crashed due to software glitch that affected as many 3 lakh traders on the financial market, right, which actually forced the government to postpone £3 billion debt sale. Similarly, there was an event in the Nissan cars that recalled over 1 million cars from the market due to a software issue, right? There was a software failure in the airbags, which resulted into a software failure, right? Starbucks was also forced to close about 60% of stores in the US and Canada due to a software glitch. Amazon's third-party retailers saw their product price is reduced due to 1 penny due to a software glitch. Similarly, there are vulnerabilities in Windows 10, which also, surfaced the bugs and helped, and sorry, not helped, but affected the Windows 10 operating system. So why are all these things happening? We know that software is it's a complex thing, right? As it consists of many different pieces tied together. It depends on the technology being used, on which the application under test is built, coding that is written by developers, techniques, different layers like database, networks, servers, etc. Therefore, it is very, it's very likely that there can be errors in the software, which results in a lot of risks. By that, I mean anything that has the potential to cause loss of something of value. So it can be functionality issues, it can be security issues, or it can be reliability issues or performance issues, right? So as we have just considered these examples, all these falls in these categories. There was some issues in the technology, or maybe there was all these events that have happened in the past is because of these software glitches. Now, today's technology world, if we look, is completely led by machines, and machines are driven by nothing but softwares, right? So it results in the risks carried by the architecture if not designed properly. Software testing is the cost-effective solution or a method to all these risks and worries. It is the only way, I would say, that helps in building confidence in the software and the system being released. So, okay, so this is the agenda. So let's talk about what is the need of testing. So software bugs, as I mentioned, it could be expensive, as we have just seen these events, and it could be even dangerous and cause monetary or human loss. So what are the objectives of testing? So as I mentioned here, few of them, let's discuss very quickly, because there are a lot of slides and a lot of other topics that I need to talk about. So it prevents defects. No doubt, if we perform testing, it's the most important purpose in software testing is to find defects, to find different defects in the system, to prevent its failure or crash during the implementation. And if they left undetected or unattended, it can harm the functionality of the software. Next is we need to verify the fulfillment of the requirements. So it says that the essential elements of testing should be to fulfill the customer needs. Testers perform testing to ensure the implementation of all the specified requirements, creation of all the possible test cases, and verification of the functionality in simple terms, right? We have requirement traceability metrics where we need to map the test cases with the requirement to ensure that the full coverage is there. We need to make sure that the system is complete. That means that when we do testing, it ensures the implementation of requirements along with the assurance that it works as per the expectation of users. So this is called validation, verification. It can be manual testing, it can be automation testing and all, right? And there are different techniques like black box and white box. I'm starting with this basics, but just to wrap this up really quick, then we have building confidence in the system. So obviously, when we perform testing, the another objective of testing is to improve software quality. So, to improve software quality, which ultimately um, helps in building the confidence in the system when we find bugs and make it bug free. So efficient testing process results in a better product, which increases the overall quality, and hence it also increases the what should I say, the customer satisfaction and lower maintenance cost. Obviously, it reduces the risk of level of risk. So another objective is every product is unique in its own sense and may contain significant number of uncertainties from different perspectives, like budget, technology used, implementation of the features, etc. So if these conditions are not controlled, it will impose potential risk not only during the development phase but also during the whole SDLC, or the life cycle of the product. So integration of risk management process is important to identify any risk as soon as possible. Then we have to provide sufficient information to stakeholders. Obviously, uh, when we perform testing, we create artifacts, right? And we give sufficient information that needs to be provided to the stakeholders about technical or any other restrictions, risk factors, etc. It can be testing reports, test coverage, etc. And comply with contractual and legal requirements. Obviously, when we are performing, we need to make sure that the product is being developed for a specific region, that it must follow the legal rules and regulations of that particular region. So there are different international standards like ISO, IEC, IEEE and all those standards are met properly or not. So understanding these objectives of testing, I have just created another slide that depicts testing as a career, right? So can anyone point out or just give me, looking at these visuals, what are these? Just give me in one word that why testing as a career is a good option. Anyone?
Industry needs testing of everything. For example, performance testing.
Yes, yes.
uh,
So
uh,
yes,
it's a very needed skill for everywhere. We need to for every um, what we say for every product they need to be a testing before it go live.
yes, perfectly fine. So it's a specialized job, right?
Yeah.
So why I'm saying it's a specialized job, because you not anyone can test, right? So it requires thorough knowledge of the application under test. You need to have a good knowledge of the UI UX design, development patterns, as well as the analytical and communication skills. And when I say automation testing, then programming skills also. It is challenging. So testing is complex but not boring, in a way that you need to think to design more test scenarios in order to break the system, or rather to find more bugs in the application under test and make it a healthy application. You need to solve problems constantly. So it's a challenging job. It is important. Why it's important? So as a tester, you are acting like an end user, and you are assuring that customers are being delivered a quality product. So you need to act like an end user. Imagine an organization having no one to find bugs before software is delivered. It results organizations having poor reputations, being a poor product, and unloyal customer base as well, I would say. Creativity. There's a lot of creativity in testing. So when you act like an end user, as I mentioned, while testing, you need to be creative enough to create test cases where there can be any deviations. So you are breaking system or something by finding bugs, making sure they are fixed before the application is released to the user, right? So you need to be creative while creating test cases. There's a constant learning in software testing. So no matter you are writing test cases, test scripts in automation testing, there is always a scope of learning in software testing career. So your work will need to be, will never be stagnant, as you will be constantly growing and improving, your testing practice. This is collaboration. So as a tester, you will work with many different groups of people, from I would say stakeholders to developers to business analysts who have the thorough knowledge of the uh, application or of the domain the application is built in, right? As well as database teams. So you will be communicating with passionate people who share the same interests as you. You will work on projects from start to finish, where you will be presenting to different stakeholders. So your communication skills will also be practiced, right? So collaboration is required here. And the one is, there will be many paths, right? So when you being a tester, it's a flexible career because of the business and the technique. Should I say, technically focused roles available, right? So in automation, you will have programming skills, right? And this means that there are endless opportunities from progression, and can go in any direction, right? There can be possibilities to gain cross-functional skills that can be utilized across the whole software development cycle. So being a tester, when you're interacting with a business analyst, you will gain a knowledge on the domain. When you're interacting with developers, you are obviously understanding the technical documents and the workflows of the application, right? So you are writing test cases, but in a way you are having an understanding of the application, be it in insurance domain, be it in e-commerce, or be it in telecommunication. So as a tester, uh, you get to test new cutting edge technologies as well, right? So there are many parts. So if I say technologies, you see from Java to C# to Angular based to SPA, single page applications, you will understand that how we need to write test cases for different cutting edge technologies and how to test them actually, right? Automation is the next thing. So so you could be testing software for a website, or you could be testing for mobile apps or content management systems. And obviously at last it is rewarding as well. So definitely testing is a way to showcase um, and add value to your organizations. So when you're in an organization, you're helping to make their product better by testing. So you are meeting organization goals and objectives by improving the organization's product. So you will probably notice your impact as a tester every day on the job. Any questions so far? Okay. So what is testing? I think we have covered. It's a method to check whether the actual software product matches the expected requirements. So quality first, verification, validations, and all. Just try to show you this this phase, right, which actually is discovery phase, where we analyze the requirements analysis. Planning phase, we plan the strategy, plan the tools, what tools needs to be used. We design the test case in the designing phase. Test scenarios, we write the scripts, we set up the environments. In the environment phase, software, hardware, network configurations. In the execution, we execute the test cases that are that we created in the designing phase, and defect tracking, defect analysis and reporting, and finally the test closure by identifying that the end criteria is met. We prepare a report and metrics and all. Okay, so what are the benefits of testing? It's quality product, better utilization of time and resources, business optimization, security, because you have tested, you perform different types of testing. User experience, you're testing it for UI, UX, customer satisfied, and obviously more profit to the organization. So just try, there are many more as well, but just try to make you understand that what testing is, what are its benefits, and how we can see testing as a career.
Hello, sir.
Yes.
Sir, what about verification and validation? What is mean by that?
Yeah. So validation and verification, these are the two static. This is second slide. Yeah. Right. So there are two types of static and dynamic testing, right? Verification includes like reviews, peer reviews kind of things, right? Where you are verifying, matching the requirements with the by having a static, you're not performing anything like we have in dynamic testing, where you do the validations, you actually execute the application, right? And you give some input to the application, and you verify that you validate that the output is as expected. So these are two static and dynamic methods, which is verification and validation, right? So there can be walkthroughs. So if I talk about verification, there can be walkthroughs with the SRS, with the high level test scenarios and all. So you are doing some you're not executing, but you are verifying it with documents, and you're doing the peer reviews things. But in validation, you will be executing the test cases. I hope I'm able to answer your question.
Yes, sir. Thank you, sir.
Thank you.
Sir.
Hello,
Yeah.
sir.
Yeah.
So please little bit explain static and dynamic in software testing. What is the way of static or dynamic
Yeah.
in
So
software testing?
as I just mentioned, in verification, uh, verification is a type of static testing. So you walk through with the documents. You do the you got the specific requirement specific document, right? So you write high level test cases, you write low level test cases, and someone will do peer review of the test cases with the requirements. So that is whether the test cases have covered the requirements or not. But in dynamic, you are actually doing the testing. So you are executing it, like you are launching the application and you are logging into the application or the product or the website, and you are entering some input and validating whether it is as expected or not,
Okay, sir.
right? So just try to depict some testing methods, static and dynamic. We have white box, black box, and gray box. So like white box is basically, I'm not going into details because today's topic is more into the trending trends, sorry, the technology trends in software testing. So just trying to touch at high level, right? So we have approaches: white box, black box, and gray box, and different levels like unit testing, integration testing, system testing, acceptance testing. There are a lot more uh, testing types. Then we create the artifacts like the test plan, test cases, testability metrics, test scripts, and test suits. So that's about an introduction on software testing and types. Now, any questions anyone has before I move on to the next? Hypertest automation.
Hello.
Yeah.
So does that V for validation and it comes under V model?
Yes, it comes under V model. Yes, we call no it's V model. It's a model, right? We call it V model
Yeah,
because
yeah,
it's in a V shape, right? But we have different models
yeah.
as well. But verification and validation is it's at a broader level, right? You need to
Oh,
think
oh, yeah,
that
yeah, yeah. Okay,
validation.
got it, got it, got it. Thank you. Yeah.
Thank you. Okay. So we have hyper automation. What is hyper automation? Let's go by the definition first. So as per Gartner, when Gartner introduced this word in 2020, since then there's a it has gained a lot of traction, right? And many businesses have begun to look into, how they can actually, use or implement hyper automation so that they can have the most out of their product. So it says that hyper automation deals with the application of advanced technologies that includes artificial intelligence and machine learning, right? So straight away, I've jumped from the actual topic, which is the trending technology trends in software testing, which is one of them is hyper automation. So that includes artificial intelligence, machine learning to increasingly automate processes and augment humans. Hyper automation extends across a range of tools, right? So it's not like simple automation, right? So we need to understand automation is actually helping, why we do automation. When if I talk about years back, whenever there is something that is repetitive, whenever there is something which is stable, these are the two requirements, right? Something that is stable, something that is repetitive, automate it. Just try to connect my insights or whatever I'm saying in QA world, right? As a quality in quality assurance, right? Or quality control or testing. So automation helps whenever there is a repetitive or a stable thing, we automate it at a smaller scale. But hyper automation is basically we are using multiple automation tools that actually helping intelligent automation to scale automation initiatives, right? So it's not only we have a tool like Selenium, we have automated it, it is hyper automation. No, it is an implementation of various tools to so that the automation can be scaled up, right? It also refers to the sophistication of the automation. Discover, you need to discover the things, you need to identify the current continuous CI/CD things, right? So I'll be using few terms, right? They might be new to you, or you might have heard about in your academics, or maybe who have some experience or might be working on. They might can relate, right? But in the subsequent slides, I'll try to cover those. So in CI/CD, which is continuous integration testing, right? You identify the current processes, and you analyze, you identify the bottlenecks, how you can improve those, what tools can be implemented. You design those strategies, you implement those, you measure those, monitor those, reassess those, and reevaluate and improve the process. So this is as per the
the definition. So when I'm saying hyper automation, it also refers to the use of the obviously the technology with the you know with a less human intervention, so that the any task can be performed faster, any task can be performed efficiently, and ultimately that results in the possibility of uh, that reduces the possibility of human error, right? Why we are automating? We are make we are trying to make the product faster to market. And how we can do that? By hyper automation. And hyper automation is a combination of various tools. So for example, testing for various regression defects on a website would like you do regression testing, right? Which is whenever a defect is fixed, you test the surrounding areas of that particular functionality to make sure that nothing is broken that was working earlier. So if someone has fixed the bug, developer has fixed the bugs, the QA will only test the bug? No, have to perform regression testing as well. So that will be a cumbersome task, right? Maybe a bug has associated 50 more test cases around it that needs to be executed. So that becomes a good candidate for uh, automation, I'm saying, right? So you will write automation scripts and you will automate it, and it can run overnight, or the scripts will execute and it will give you the results then and there. Now, hyper automation in the QA industry. As I mentioned, hyper automation is automation of automation, basically, right? Using the latest tools and technologies, and those tools and technologies include let me talk through. Okay, yeah, those tools and technologies can be RPA, which is robotic process automation, that can be machine learning, artificial intelligence, right? So one example can be, you can think of the use of a continuous integration business flow, right? Or maybe self-healing capability, right? So in automation, we write the scripts, but when we write the scripts, it might fail because of a UI change. So one can implement a self-healing capability so that hyper automation can be achieved. There can be no false failures and no maintenance of the scripts if there is any UI change and all, right? So automation, as I mentioned, it's like the inclusion of latest tools and technologies. So how it looks at this hyper automation, it sees the automation of, as I mentioned, automation of anything that can be automated. So one should automate that. And it is achieved in testing world. It can be achieved through collaboration, through the integration of what different types of automation, like UI automation and the web API test automation, right? So we have a client server architecture where we have the APIs, web services, and we have the UI. So if you want to achieve a thorough testing, you will integrate or you collaborate these two types of test automation with RPAs, with the AIML, and what we call codeless or low code automation. So if we try to bring these latest technologies, it will accelerate the different it will accelerate the whole testing, STLC testing cycle, and improve the product. And if you look at this, it will obviously, you are increasing the speed, so the product is available in the market in time, or rather before time. What we are achieving through that? A better productivity. We are efficient because we are using we are properly using the resources, be it human or be it tools, so it is cost effective as well. And because humans are tend to prone errors, right? So this is accurate as well. So once you automate something, you test it that yes, it's not like you just automate it, you need to test those scripts as well, whether there is any loopholes and all. So once that is done, those scripts will put less risk on accuracy. So we are achieving time to market, efficient and accuracy. Ultimately, it is helping in better productivity and all these things. So if I move to the next slide, hyper automation is it involves the orchestrated use of multiple technologies. So as I mentioned, all these technologies, low code packaged softwares, right? We have um, the configuration management systems. We have Jenkins, where the pipelines can be created and the builds can be run and testing can be included in between. So combination of automation tools, package softwares, intelligence by including artificial intelligence and machine learning, we are achieving hyper automation, right? So automation, if I just talk about autonomous testing, right? We have autonomous testing, like we are going autonomous from automation. It is independent. We have standardized the processes. So we have standard test management tools, we have standard processes, we have toolkit, and we have proper reporting. Obviously we are reducing the cost and improving the efficiency. We are also blending human and machine intelligence. Let me go to this slide so that you can relate it better. So this is the DevOps cycle, but this is hyper automation through continuous testing and automation testing. So as I mentioned, it is autonomous, standardized, reducing the cost, and the blending the human and machine intelligence. We are improving it. We are creating solutions at enterprise level which are domain agnostic, right? So a solution can be created on an automation solution is created for an insurance application, should work on another application which is a website or same, but on a different domain. So those solutions which are domain agnostics, that will also help. And seamless, making testing continuous. And we can have specialist pools, domain experts. So by including all these parameters, we are helping in achieving hyper automation in the organization. Also, obviously we have already discussed this. Faster, easy, seamless, no need to talk again. It is scalable also, right? So when we need to think that the solution that we are creating is scalable. So for example, if we have created something right now, it is later on it is scalable to the other requirements as well. Could be for example, if you have not included something like parallel testing right now, but the solution is such that it is loosely coupled, right? That the test cases are loosely coupled with the data, and the structure or the framework, I will talk about framework later on, is so loosely coupled that the parallel testing can be achieved later on, right? And also the integration, the solution should be that the integrations with the cloud, with the CI/CD tools is also considered while creating the solution. So if I talk about the functional, non-functional testing, we just try to cover the tools. So when we do hyper testing, in the functional testing, we have like unit testing, code coverage, API testing, regression testing, and acceptance testing. So we have different tools available. So if we are doing unit testing, we can use NUnit, JUnit, Jasmine, Karma, right? These are the tools that can be used at this level. So before, if you assume a CI/CD continuous integration, you can easily trigger the unit testing by using these tools. Similarly, for code coverage, you have Jacoco, SonarQube. API testing, we have a in the market free tools like Soap UI, or a proprietary tool from the same company, SmartBear. We have Ready API. For regression testing, we have many tools, be it Selenium, which is top in the market for web. We have Test Complete, which is again a smart beers tool. We have Telric Test Studio, Functionize, Perfecto. These are all, these are also AI, artificial intelligence tools, Apply tools, Mabel, that actually gives you, help you to design your solutions for to implement artificial intelligence, right? Where we include some, say, NLP, which is natural language processing, computer vision, all these kind of things, process mining, and that. We have acceptance testing, where we can use Cucumber, SpecFlow, and Inspec. So all these tools can be used to achieve hyper automation. Non-functional side, we have many. Performance is a bigger umbrella, right? So in performance, we say Load Runner, Load Ninja, Telric Load Testing. JMeter is a free tool which has come up really fine, that you can automate your performance scenarios. Security testing, you have SonarQube and all. Usability, you can use User Zoom U. Compatibility, you have Sauce Labs and Browser Stack. Accessibility, you have X, DevTools. And mobile testing, you have Robotium, APM, Calabash, iOS driver. So there are many tools that can be integrated, that can be used to create the solutions and integrated in the hyper automation, so that you can achieve the the benefits of hyper automation in your organization, right? Any questions so far? So one thing I would like to touch here in the continuous in the hyper automation is in the QA, right? So as I mentioned that in QA, when we design solutions and frameworks, we come across okay, let me talk about frameworks first. So in test automation, we have different kinds of frameworks, right? Like data driven framework, we have keyword driven, we have modular, we have hybrid. So just take an example of data driven, which is nothing but you are separating the data from the scripts. There are no hard coded values in the scripts. Everything is separated. The data is supplied from external data sources like Excel file, CSV, or plain text file, right? So test data and management and test environments. So this can be one step in towards hyper automation in QA, right? You can automate it. You can provide various parameters or data combinations that are needed for the testing the application code, right? So test data is one thing that can be looked into hyper automation, where you can use AI tools and identify the different patterns, right? Another is the application under test itself, which is uh, um, because this is what you test, the application under test, right? So the development code, the only thing we can automate here is the availability of code under test. So when you implement a CI/CD pipeline, that's really helpful in automating the process by packaging and deployment of an application to the right environment for testing. We have test execution agents also, right? So it is the process of basically identifying the right automation platform to execute the test cases. So you can have multiple agents where you can achieve parallel testing, right? And you can implement that in the CI/CD pipeline. So in a way, you are actually enhancing your solution that you have built, right? You have built a framework, and then you have integrated it in CI/CD pipeline, and you're using a different agent, different tools or cutting edge technologies to achieve faster testing, continuous testing, right? So these are the different things. So in hyper automation. Okay. Any questions before I move to Agile and DevOps?
Hello, sir.
Yeah.
Sir, what experience can I gain as a intern tester?
As a, sorry, I didn't get you. As a
Means I have to do internship in testing.
Okay.
So what can I experience in that?
Okay, as I understood that you want to know as an intern, what is your first step towards testing?
Huh.
Okay. So as I just mentioned, testing is, I've explained what testing is, right?
Yes, sir.
So you need to, you need to identify, or rather you need to, first of all, it's not like you straight away jump into hyper automation. You need to understand the base first,
Yes.
right? So if you're doing an internship, you need to understand what is manual testing, what are different types of testing, right?
Yes.
I have included just few of them, and there are more than 30 types of testing,
Yes,
right?
sir.
What is manual testing? What is the software development life cycle? What is the testing life cycle? So
Yes.
once you understand those, how the testing is performed, what are test cases, what are data inputs, what are the basic priorities, severity, all this is very basic in testing, right? So once you
Yes.
understand testing, you need to gradually understand, or the side by side, what's the latest in the software testing, right? So obviously automation is one thing. You need to have, first of all, the manual testing skills, then you need to have the automation skills, and then
Yes, sir.
side by side you can have the hyper automation, which is not straightforward because it includes lot many tools, programming skills, how the tools are integrated and all. So once you have an understanding of this session, we have more topics in the trending technologies. You can have more insights, right?
Yes.
But as an intern, I would suggest to go with the basics first.
Yes, sir.
Okay,
Thank you, sir.
thank you. Right. So Agile and DevOps. Anyone understand what is Agile and DevOps? DevOps, we have just talked a little bit, but yeah, go ahead.
Agile is a methodology to work.
Yes, it's a methodology to work. Great. Anyone else?
In that we do the work in sprint wise.
Yes, perfect. Sprint is one terminology there. Sprint wise, yes. Anyone else?
Change requests can be accepted at any stage, I guess.
Yes. Just a basic so that everyone can relate.
In Agile, many
Can I-
meetings are present or available.
Who is available?
Means we
Meeting,
have to
grooming
conduct
sessions, conduct the meetings
Yes.
different meetings we have to attend in that
Yes.
agile
Yes.
methodology.
like grooming session.
Grooming session, planning.
Yes. Planning. Exactly.
Yes,
Perfect.
and
So you
Planning
have
meeting,
daily
daily
stand-up
stand-up
meeting
meetings,
also.
sprint review meetings, sprint retrospective meetings.
perfect. Perfect. So you have a fair understanding of it. So let's recap it. So agile in simple terms is something that is able to move quickly and easily, right? That is what we call agile. Agile methodology, yes, it's a method that is to manage and execute the project. How? By splitting that project or breaking it up into different phases, right? So that fast and continuous improvement can be achieved at every phase, right? After initiation or after the initiation of the sprints, right? We call sprints, sprint cycles, through a process of what we say, let me go to the, yeah. So this is the process. So through the process of analysis, planning, design and development, executing and creating and implementing and executing and reviewing and monitoring. So this is the thing. But as you can see how it has come, right? So with the requirement of accuracy and speed, we need the agile, right? Why we need agile? Because accuracy and speed was required. We wanted the development process to be in a paceful manner and more accurate, and the quickly changing requirements. So when the requirements are changing frequently, we need to make sure that we have the things in iterative manner, right? We can review the things, we can improve the things, and we can collaborate in a proper fashion. So all these organizations these days, they are imbibing these DevOps, which is actually as a response to the demand for accuracy and the speed. And this agile is to the response to the quickly changing requirements, basically. So both these are the demand of these two things. The different processes, we follow different practices, processes, there are different tools, right? We use Jira as one tool, Atlassian product, which is widely used. We have different rules that everyone needs to follow, as you all mentioned. We need to attend sprint calls, daily calls. There are short meetings where everyone needs to, you know, provide their work updates, what they have done yesterday, what they are doing today, and what are the impediments, if there are any, right? It's a teamwork, basically. And from that, there will be a constant feedback as well, right? So if I talk about the uh, principles of this agile, it will be, one needs to interact over processes and tools. So when you're going to meetings, you're actually interacting with your peers, right? Be it a developer, BA, or your project manager, but they're interacting over the processes. You need to follow the sprints, you need to follow the scrum calls, right? There are different methodologies, and you have to give your update in the tools, right? And you need to provide the updates of a comprehensive documentation as well. You need to provide the documentation of your work, right? There will be constant feedback from the peers. So if I talk about this in this slide where the requirement analysis is always happening. So requirements, in the requirements, the requirements analysis is done. It is defined, which is the identification of the, what should I say, the current state of the application or the product being developed, and the expectation from it. So that is what is done in here. In the planning phase, it actually includes the sprint planning, right? Where we identify a backlog of items, we assign those items to the individuals, we assign the time frame there, right? And the arrangement of the various teams, right? So there can be multiple agile teams, and we identify the duration of the sprint, whether it's a 2-week sprint and all, and we identify the tools that are needed to plan this. Then we have the design and development, which is actually a more collaborative way, right? So from the beginning of the process, the end user involvement and the feedback is also important here. Also the when we say the creation and the implementation phase, it actually includes the frequent development through sprints, right? So in the sprint of say 15 days or 2 weeks, something workable should come out from that sprint, right? So if you're developing a product or website, after that sprint, there's something that, yes, this task is workable, it is working, whatever task identified in the backlog, right? So, and the feedback is also received on the testing, where we have the retrospective meetings. We refine the we have a backlog refinement meetings, what items are done, what items are in progress, right? And any changes that are necessary are done there. Then obviously the review and the monitor phase, where the team needs to ensure that and evaluate, rather review and evaluate the key metrics to identify the success criteria, right? So there are different agile methodologies, like we have Scrum, we have feature driven development, we have adaptive software development. So these are different uh, methodologies in agile. If we have a look at this particular diagram, where I've tried to give you an insight on agile development by embracing quality first and driving test-driven development. So there is a term called story. Any requirement comes as a story, right? You understand the story, you add a single test to it, add production code for the test, run all tests, whatever tests are added till now. If the result is pass, story is complete. If it's a fail, rework is here in the test, right? And if the story is not completed, again goes back and more test cases will be written here. But where it's a the testing or is done here, like you understand the story, you implement the story here. You have implemented the story then and there, and then you write the test for story. After the implementation is done, you're writing the test and then you're running the test. So it's a failure, you're again running rework. But here it is iterative. Whatever story, whatever that particular task is done, you have written you have added the test then and there. Once that story is delivered, you execute it. So it's a faster feedback, it's a faster development, it's an iterative development also. So there are a lot many advantages of agile. So this is again a trending trend. Every organization is using agile approach, right? They are emphasizing more on the incremental delivery, team collaboration, right? You actually interact with a lot many teams, be it BA, be it developer, right? You are in the involvement of continuous planning by these meetings, retrospective meetings, refinement meetings, and obviously daily meetings. And what you're getting here, you are continually learning as well, right? So you learn from one sprint. You don't want to uh, repeat that mistake in the next sprint. So in an iterative fashion, you are completing one thing, and in the next iteration you are improving, you are learning, and you are improving. In that way it is more efficient and helpful for the organization, right? So in as I mentioned that the current organizations are you know uh, every organization is actually, so there's a lot of demand for a faster product these days, product life cycles, right? So that the software products can be released quickly and can be released in small autonomous teams. Thank you. So agile helps in improving the it actually improves the collaboration among the various teams and has different methodologies as I just mentioned above. And DevOps, we call it dev desktops. I try to relate it uh, with the QA, right? So this is the same picture you can see here. Planning, coding, building the product, testing and releasing, deploying, then comes the operations, then monitor, then again plan, code. So it goes that way. It is DevOps. You can replace it with the test ops or QA ops here when the QA comes into picture, right? So in if I go with this statement, in order to achieve enhanced quality and rapid delivery, all testing and QA initiative activities must be performed in the CI/CD pipeline. So it is basically the integration of development and operations, right? So we implement all our testing activities in CI/CD pipeline, which actually helps in all these things, increase speed and all, right? So it's DevOps is all about actually uh, streamlining and automating the entire process that is involved in the SDLC, software development lifecycle. It actually also involves the proper agile testing best practices are imbibed, and continuous testing, continuous integration techniques, right? It's not only like we have placed QA over here. We need to make sure the tools that we have used are efficiently integrated, and the best industry techniques are employed to to have a good execution of the test cases and a better quality results. So it's actually plays a very important role. Testing in DevOps, it's actually playing an important role to have a successful end product. Also, you will notice here that that QA is involved earlier in the life cycle, right? Right from the initial, phases where you have sessions and you are doing Scrum meetings. Everyone is accepting on the requirements by having meetings, be it QA, be it development, project managers. All the stakeholders are in one meeting. They're discussing that requirement. They're accepting the acceptance criteria, which actually helping the development team to start writing the code against that requirement, and that helps the testers to write the test cases against that requirement, because that requirement is accepted and understood by all the stakeholders, right? So developer writes that code in an iterative manner, and QA starts writing that tests. Once the sprint is over, that functionality is available, and moreover, the automation testers can start writing the test cases as well, test scripts. At least they can start writing the framework, right? And once the UI is available, they can start writing the automation scripts against it, right? So it's helpful in many ways. Like you will have an instant feedback, as I mentioned. If there is anything going wrong, it will be uh, the feedback will be given then and there, right? uh, Requirements can be refined. That is another important aspect of DevOps or Agile and DevOps, right? We are encouraging here the autonomous testing approach, which is also a very good practice, right? It is independent. Everything is handled by the tools, right? If we are considering the scalability and flexibility, so when we are integrating the tools, we are making sure that it is flexible enough to talk with different components of the framework or with the CI/CD pipeline. What we are avoiding is rework as well. If I talk about Agile, we are avoiding rework by correcting the thing in the same iteration or in the same sprint. So rework can be avoided, which is ultimately helps in, it's a cost effective method, so it will be less expensive change to the project stakeholders or to the organization at a bigger level, right? So these are the uh, benefits of Agile and DevOps, which is very much in adoption in the organizations worldwide. So that is all helpful in this I have just included. And if you look at this particular slide where the market adoption, you can see here manual testing used to happen in 1980, waterfall methodology. Then the bulky automation tools were used in 1990 to 2000, right? So different development approaches were used. There were tools that have that record and playback feature, but not many features were available. Then more automated tools and open frameworks came in 2000 and 2010, like Selenium and other tools that were used and to create the frameworks. And then in 2010 to 2018, the DevOps and continuous testing, continuous integration and deployment came into picture, which is very much in flow these days. And that has helped in scalability of the whole SDLC cycle, right? And autonomous testing is these days is another or the ultimate thing these days in terms of autonomous testing using machine learning and artificial intelligence. You can see a case study here. Netflix, it's a 3 weeks release cycle to daily release cycle, right? Through test automation and DevOps. And in Amazon, code releases every 11.7 seconds. Can you believe this? Every 11.7 seconds a code is being released just by implementing the CI/CD and cutting edge technologies. So this has happened just because of the implementation of CI/CD Agile and DevOps. Quality engineering and quality at speed. Okay, so this is a broader topic here that in the QA terms that I would like to discuss. So what is quality engineering? Let's go by this. Quality engineering is nothing but it is a practice of implementing quality checks throughout the entire product development cycle. So it's a very big topic. I have included few pointers here and few slides that can help you understand in the understanding of this. So at every point we need to put a quality check. It is the application of quality engineering practices to the SDLC. And third point, very important, is in software quality engineering is closely integrated with existing Agile and DevOps processes. What are its main goals? Its main goals are process control, devising standards, data analysis, test development, issue identification and solution, follow-up to ensure corrective actions. There is one end-to-end approach for it, right? What is that? So quality engineering can be implemented. The first one says is the stakeholder analysis. This is one of the most important technique in order to interact with the most valuable influencers in the quality engineering, right? So in order to implement this, we should have a stakeholder analysis first. Then there should be a sense of urgency. So it's a must-have to initiate the change to quality engineering, right? It can be used by different practices. For example, we have warning signs, we have benchmarks, etc. Third is the communication plan. So whoever is implementing the quality engineering, that leader must build and execute a communication plan that is adapted to each transition, right? Various models should be used, like for example, all hands, workshops, or maybe one-to-one interactions, right? So communication plan is must there. We have community of best practices, which is this is also a new thing, right? That can help in proper dissemination of the practical knowledge, right? So there will be a community of practice in an organization that will be imparting the knowledge. By having regular interaction, individuals will be able to learn from their peers. Quality first approach we need to keep, right? Creating an outlook of quality first approach across teams and developing values so that every team member has a sense of responsibility to develop, test, maintain, and deploy a quality software product. And obviously there needs to be organizational change. What I mean by that is we need to make sure, we need to analyze or reassess our organization in terms of upskilling the resources. We need to hire the required resources to speed up the process if the skill set is not available, right? We need to assign like responsible first line teams for quality and evolving accountable roles to enable quality. Third, there are a few more, and that is faster development, right? So we need to encourage agile methodologies, as we just talked about. So in quality engineering, we need to make sure proper frameworks, agile methodologies, right, where all the stakeholders, BAs, developers, and testers, they are on the same page and at the acceptance level, and ensuring all stakeholders have clearly understood the requirements. Again, iterative approach, we understood that. We need to develop and test the systems in an incremental way so that the bugs can be identified early and can be fixed. That helps in, that, right? That helps in cost saving as well, and which helps in avoiding the rework. Then we have automation accelerators. So we should have a pool of application agnostic test automation frameworks. In quality engineering, there can be a testing center of excellence of community of practice where there are already built-in pool of application agnostic test automation frameworks or maybe utilities that can be used in a way like plug and play, and they can be enhanced or they can be tweaked as well to the new requirement in order to save time. So there already available solutions we can have in the automation accelerator section or the team. Then we have the end-to-end testing approach. So we should have solutions to test the web services and UI layers. So in quality engineering, if we have this approach, which is very, very important, we are not testing, if we are not testing, we are testing individual pieces as well, but we are testing the application end to end. What I mean by that is, we have web service layer, we have UI layer, right? We have any microservice layer. So we should have a solution that tests the workflow from the start to the end seamlessly, right? And based on that, we can build regression tests. So incrementally, and once that is ready, we can connect it to the DevOps cycle, pipelines, and the tools to automate the test execution process. So that will be an end-to-end approach. Another will be an intelligent automation, which is again implementing AI and ML based solutions, artificial intelligence and machine learning based solutions and automation tools to identify the issues early, or rather even before they occur, with minimal human intervention. So these are the main things. Let's move to next one, which is digital age. So you all know that with the advancement of the upsurge in the development of digital applications and requirement of a requirement of a rapid product delivery, we need to deliver the product as fast as we can. There has been a significant disruption in the software application testing approaches, right, or techniques, and business strategies, I would say. So at the same time, there are challenges in testing the software product end to end. And what are those challenges? Those challenges are change in the digital landscape, disorganized processes, rapid change in the technology. You can see there is a change in the technology from earlier we used to have applications built on our legacy systems, right, mainframe systems, but nowadays we have say Angular based applications. We have single page applications. They're literally single page applications. So they do not, user does not need to, or sorry, the front end does not need to communicate with the back end to get the data. They can get the data from the front end level. There are microservice architecture, right? These services make a call to the database at the back end and fetch the data. So the rapid change in technology, the time to market, as I mentioned, we need to be super fast, and we need to also consider that when we are at a good pace, we also need to be cost effective, right? And there's an increased demand as well. So this is the digital landscape. This is the digital age, and we need to upscale quality engineering requirements, but because these are the challenges we have, where we have disorganized processes and all these things, we need in quality engineering, I mean, if you look at these challenges, there are enormous new market opportunities as well. So to keep up with the latest trends and adding more value to businesses, what currently organizations are finding, currently organizations are doing is they are finding improved ways to test the system's quality by leveraging AI and data, right, to drive the strategic models of new solutions that actually lead to improved efficiency, higher value creation, and better customer experience. So they need to identify ways. What are those ways? Obviously, as we have discussed so far, agile, DevOps, hyper automation, cutting edge technologies and all. So we need to think that as well, right? So any questions so far? Am I going too fast, or no? I think we are fine, but any questions so far, please?
No, understood.
Okay, perfect. Thank you. Okay, let's continue. So so far we've understood that software quality engineering is a practice of implementing quality checks, right? It is the it applies rigorous quality checks to each stage of product. Now, as I mentioned, there are opportunities, but before opportunities, let's say understand what are the driving factors. So quality engineering will be driven by obviously intelligent automation that uses artificial intelligence, machine learning, DevOps, DevSecOps, which is related to security, cloud computing based technologies. This is another trending technologies in software testing. A lot of organizations are moving really quickly so that they can reap the benefits of cloud computing, right? And that has many advantages. Improvement in continuous testing, right? So we need to make sure that we are doing continuous testing, but we are improving the we are making it more efficient also, right? We have performance testing, which is again a big umbrella. That is, I'm not including what it is, but yes, that will be driven by that is one of the driving factors for quality engineering. And security testing, because when these applications are moving to cloud, they are interacting with different tools in the CI/CD world. We need to make sure that the security testing is also performed for the application, right? Or be it for different domains, I would say, then or platforms, I would say, we need to make sure that it is secure. But more importantly, it is the cloud computing where we need to think on. What are the opportunities? So before we go into the opportunities, as I mentioned, these driving factors. So with the SDLC reducing today, right? The software development cycle, earlier it was maybe 6 months or whatever, but these days the time frame is reducing, right? So when the time frame of software development is reducing, how can we keep the software testing time as it is? So we need to reduce the uh, uh, software testing time as well by performing continuous testing, and that can be achieved obviously by these cutting edge technologies like cloud computing, AI, machine learning, and all. Quality engineering will be supported by scriptless automation also, right? And self-healing capabilities. So these Selenium scripts or any other tool, not Selenium, I would say any automation script, I would say, right? Selenium is a very advanced tool. It has come up with lot many features, very robust. But any automation tool which does not have these codeless capabilities is prone to failures, false failures sometimes, or maybe rework maintenance is high. So we need to have self-healing capabilities that these tools offer, which are codeless tools. We're calling it codeless because the user of the tool does not need to have any knowledge of the code, right? I'll cover that in that section. But quality engineering will be supported by these things. At the same time, will be supported by Agile, DevOps, and continuous integration, continuous delivery methodologies. And it actually needs to facilitate a broader level of collaboration across the organization. So cloud infrastructure and digital technologies had advantages in test automation coverages, with the clients identifying the need for security and performance testing capabilities that needs to be essentially connected to the software quality engineering lifecycle. So that considering all these factors, investments in testing environment management has become important, that if employed can lower the cost and provide highly automated environments. So if you think people who are working in or have some experience in this automation testing, they are creating the frameworks, right? Keep writing the scripts, right, from 100 to 200 to thousands, right? But as considering these driving factors, now organizations have started uh, you know investing heavily in the testing environment management, be it moving to cloud or you know creating their strong CI/CD pipelines, and lowering the cost of the HTLC. We have, considering these challenges and all, we have the opportunities also. So the pace at which the technologies like intelligent automation and AI and all are moving is being adopted has created interesting changes in the software delivery lifecycle, right? What are those interesting changes? There are many. There are changes and there are challenges as well, and complexity also. And if they are taken positively, they can result in a lot of opportunities to advance the software quality engineering practice, right? So you can think of creating manual test cases being converted to automation scripts. We need to look far beyond that, right? So what we need to look far beyond, we need to look end-to-end test scenarios from requirement phase to the production, right? So that is one opportunity in this quality engineering. We need to create those frameworks. We need to identify the the end-to-end test scenarios. For example, if we consider of a policy life cycle, we need to think right from the inception of in an insurance domain. If I talk about from the inception of the policy, we need to consider what all stages policy goes through till the end. So we may need to make sure that all those scenarios are considered in the end-to-end testing. Early engagement with development teams, right? So we need to make sure that the configuration teams, the release management teams, environment management, and also the deployment teams, we need to make sure we collaborate, we engage with them early in the STLC. And thinking early regarding scaling the application. So when you are, you build a solution or application is being built, so we need to think early that once we scale the application, what are the challenges we might face. So we need to have an all-inclusive view, right? We need to have end-to-end test scenario, as I mentioned, and we need to try to identify the constraints as you look to scale. Because if you don't think that once you scale the application, as you improve the speed of automation, because what you are doing here, you have written the framework, you have written the test scripts, your test scripts are working fine, but now you are packaging or moving that solution to a CI/CD pipeline or to cloud by incorporating or integrating cutting edge technologies, be it AI, be it codeless automation, be it API level testing. You are increasing the speed of testing. So when you're increasing the speed of the testing, it is very much likely that you might expose the other areas of constraints, bottlenecks, environments, setup issues. They might fail. You never know that once you have increased the speed of the application, your application's memory is leaking, or maybe the response time has degraded, right? Or maybe it has surfaced some setup issues, right? That the maybe the session and cursors at the database level have are not closed properly, right? So performance testing needs to be performed here. Test data setup and frameworks. So all these things needs to be considered before these surface at the speed where the automation we are trying to bring, right? So we need to think early in this, early engagements with team as well, and think early in scaling the application. So in terms of testing, we now have more areas to test, I would say. So quality engineering and testing, we have more areas in terms of cloud, AI, ML. We have disruptive technologies, right? They have exposed the surface area that users can now access. Systems are more distributed on cloud. Different devices are connected, etc. Right? We have more options when application is hosted on cloud. We also need to consider the geographical and data privacy requirements, and it is happening at such a pace that many practitioners are adopting new tools and elevating software quality engineering practice. So it is a new thing. So yeah, that's all I've covered, right? We need to consider upskilling of the resources as well, right? That is the need of the hour. That and many are adopting new organizational model in terms of right tools, nurture the talent, as they cannot compromise in quality. So providing tools and technologies, knowledge to their resource pool in order to increase the level of automation overall in and in STLC, right? And obviously the adoption of cloud computing is there. Data pipelines, algorithms to continuous diagnosis in data pipelines. So there are a lot many things uh, in testing world in the quality engineering. So the focus is moving towards quality engineering. That is one trending technologies that I would like to focus. So if we go by this statement that the quality engineering will be demarcated less by application centric approach and more by positioning it with the business goals. And quality at speed, yes, constantly evolving market dynamics and consumer behavior, they have definitely reinforced the critical role that business agility plays in helping an organization achieve competitive advantage. These benefits we have already discussed: exceptional speed to market, absorb new requirements dynamically, right? Integrated development. So I think that is enough for quality engineering. Any questions anyone has? So let me quickly move. We have just half an hour left, and I think we have.
Mukul, we have a question.
Yeah.
How to choose the field in testing in which we can master? Bhavik has asked.
Okay. So that totally depends on individual to individual. That depends on your interest. It's not. I cannot say that you go for this one particular technology and go and master it, right? I will say have a broader and a macro level view on testing. Testing is definitely going to grow, right? It's not like you master because these days organizations are looking for a full stack engineers. They're looking for someone who can design their CI/CD pipelines, who can write automation frameworks. Obviously they should have a knowledge of manual testing, right? So there is no straight answer to it. I would say have an basic understanding of software testing first. Understand the technologies. Technology is definitely going to change, right? It is changing, but the basic concepts will remain same. So once you have the understanding of you know basic concepts, be it black box testing, white box testing, then once you learn this, you will say, okay, there are different techniques, I'm generating my interest here. Then you got to know, okay, I have spent these many years in the industry where I've interacted in agile teams and software development teams, where software development interests me a lot. And now I should go for automation testing, where I should go for a C# automation using C#, right? Or Java maybe. So then you get interest in automation testing. But these days organizations are looking everything, to be honest. So not a straight answer, but I will say start learning where you fall, where your interest falls, go with that. I hope I'm able to answer.
Yes, it was clearly answered. Also, Amar wants to know what should be the career path for someone who wants to join Google as a tester. Any comments on that?
I cannot comment much on that. Google is in Google company, you're saying?
Yes.
See, testing is, be it Google, be it Amazon, or be it any other company, every organization have their own testing standards, right? So career path in testing, as I mentioned in the initial slides, it is very interesting. It's a learning curve, right? It's always learning. You will never lose interest if you are able to generate first, right? But in Google career path, I cannot comment on that, but I can only say that yes, definitely Google is one of the biggest companies. It will have a good career path in testing, no doubt.
Sure. So what we can do, Amar, is we can plan another session on these kind of topics, and we can get it answered there. Sure. Okay, Shubham
Okay.
Rawat wants to know if we have knowledge of Agile, is it important to have knowledge of DevOps and Jenkins?
No, it's not like that. Agile, we have, you know, as I mentioned, it's a methodology, right? So DevOps and Agile have just connected because they're closely related, right? Once you start working in Agile and spend good time, you will automatically understand how the DevOps work. But it's not required that you should have a knowledge of Jenkins or CI/CD pipelines, how to configure the jobs. But if you have knowledge on Agile, then you should have knowledge on how the sprint is planning is done, how the meetings are planned, how the things or the backlog is moved further so that the product is iteratively developed and delivered. So it's not necessary that you should have a knowledge of DevOps if you have Agile.
Sure. Thank you, Mukul. There's one more question from Sagar Gaikwad. He wants to know what is the difference between Agile and Scrum. I hope I pronounced it correct.
Yes, yes. So Agile is a methodology in which we have models, right? Scrum model we have Kanban model. So these are different models that fall in Agile methodology. So these are broader terms. I cannot, I mean, it explain on both of these, but these are models. If you Google this, you will get to know that there are different terms and terminologies used there and the different way of working in these models, right? You might have a Kanban board. So when you go into meeting, there will be a Kanban board and there will be one column with your name that you have these many items assigned to you. And then you're moving your items from in progress to new to in progress and further, right? And Scrum is again a different model that works on these Agile. Both are iterative, both are Agile, but they are different models.
Thank you. Another question from Ujjwal is there any scope of testing in embedded field or embedded systems?
Yes, definitely. So testing is, as I said, is everywhere now, right? Earlier it was not, but now it is everywhere. And in embedded systems, you think of IoT, which is, I have not covered this because I've just tried to pick a few of them. So IoT is Internet of Things, right? So nowadays, with this digital transformation and internet world and the devices that are connected with each other, right? You can see that in an advertisement, Amitabh Bachchan is controlling his AC from outside his house, right? So how is that happening? So it is happening over the internet. It is connected to the internet, and these devices, obviously, before coming into the market, are thoroughly tested. So I have not covered mobile testing, which is again a complete altogether different, not different, but a bigger topic. So be it embedded, be it a mobile testing, be it these IoT. So there's a lot of scope in testing. It's not like you only have in this web world, but yes, embedded testing has a lot of scope.
Okay, I guess we can move ahead now.
Yeah, sure. Okay. So next is intelligent automation using AI and ML. So artificial intelligence and machine learning, it will take the lead in software testing. You can have a look here, or let's go by this definition, that artificial intelligence and machine learning help organizations eliminate testing gaps by augmenting people's skills and capabilities to analyze real-time data. These are actually valuable technologies now, right? So if scalability and software quality are the high priorities for an organization, these are very valuable technologies that an organization should work upon, right? And the transition to automation actually saves testing time while not introducing many errors. So, just have a look at these market statements. AI is expected to reach US dollar 190.6 billion by 2025 from 21.5. It's a huge, right? And the machine learning is expected to grow at 8.81 billion to 1. Reach this from this, right? So there's a huge requirement of AI and ML in software testing especially. So testers who develop skills both in testing AI based systems and they are utilizing artificial intelligence supported testing techniques, they will be high in demand for the next few decades, I would say, because there's a lot to develop first of all using these technologies, and obviously needs to be tested. It's not straightforward, right? There are many tools available in the market. I have just listed 4 of them: appvents.ai, apply tools, test.ai, functionize, right? So they are using different technologies here in test case generation. One is using user behavior, one is using machine learning, right? One is using rapid test execution, or maybe continuous and regression testing, right? So this AI machine learning, if I talk about machine learning, it is basically transforming how we are actually dealing with our day-to-day lives, right? You can notice, you might have seen advertisements, right? It allows us to create, uh, powers to the machines, or I would say to the machines, right? Like self-driving cars we have. So there is machine learning algorithms or uh, AI algorithms are implemented over there, right? We have smart homes. We have clouds running smoothly. So everywhere this AI and ML is implemented. It's not like we have that cloud computing technology has come from somewhere. There is definitely machine learning and AI is implemented, right? Which can actually help businesses to make better decisions using real-time data. So they are getting the data, and whatever algorithms they have implemented over there, they are analyzing and parsing that data, right? That is actually enhancing the quality of testing by quickly finding the bugs. And many organizations are using AI and ML in software testing in many ways, right from visual testing to, I mentioned earlier in the slide, self-healing mechanism of automation testing tools. So there are locators. If I talk about automation testing, as I mentioned earlier, that the locators might break. There's a UI change, or a developer has changed the ID of a locator, then it will break. But the self-healing capability or the mechanism of the tools will help to identify the element automatically, which is time consuming, low maintenance, and a very nice thing, right? In a way that they parse the DOM, the object model of a web page. They parse the DOM and they parse the object properties to identify the object, right? They also use, these tools use the image recognition techniques to navigate through the application and verify the elements or the objects visually to create the UI scripts. So once you use any of these tools, you will notice that how record and play and all these things are helping in the test case generation or detecting bugs or test data generation and all, right? So as I mentioned, these tools here, AppVents, it uses AI for generating test cases based on the user behavior. We have Apply tools. It is one of the most popular app visual management and AI powered visual user interface monitoring and testing software, right? It gives a comprehensive software test platform based on visual AI and can be used by experts in digital transformation, test automation, engineering, DevOps, right? Manual QA teams can also use it because it does not require any coding knowledge and all. But yes, we need to know what these tools features are and how we can utilize these. So, okay, in the interest of time, let me move to the next, API and web services test automation. Okay. So anyone has any thoughts on API, web services? What are APIs? What are web services?
API is the application programming interface.
Yes, it's the programming interface. So as you mentioned, yes, it's the these web services and APIs, they are basically the method, the medium of communication between two applications or machines to exchange the data, right? And the interesting part is they are independent of the architecture, the structural design, technology that is being used in the applications, right? So you will see that nowadays they don't have to build the logic, right? If someone needs to fetch the weather conditions of one place, and if there is any company who has a web service to provide that data, then that company who's seeking that information can simply call that web service and fetch the information. We are not talking about how these two applications or what's the technology of these two applications are, but they are independent of it, right? And one can use it. So it's a medium of communication between two systems, two applications. And it is basically, obviously it's a code, right? It's a managed code that can be remotely invoked using a web protocol. So we have protocols like SOAP protocol, we have RESTful services, right? That actually allows you to share your application's functionality with other programs. So it's not only data functionality, as in you can, any application who wants to expose their functionality can implement that logic in the web service and expose that web service so that any other application can utilize it, right? So SOAP is a simple object access protocol, and RESTful is a representational state transfer architecture. These itself are, broader terms, but just to give you a high level of it, it's a SOAP is basically a standard protocol defined by the W3C standard, right? Which actually helps in the sending and the receiving of the requests and responses. It's an XML format basically, right? It's an XML based, whereas RESTful is a JSON. And there are different responses we receive that we need to validate. And also, first of all, let me talk about WSDL, right? We have a web services description language, right? It's an XML based language which will be used to describe the web services offered by the web service. So what is the need of API testing? Can anyone tell me? Okay.
We can check the data sharing between two services are working properly or not.
Yes, yes. But what is the need of it? So yes, that is perfectly fine. Let me just give a thought on the if I talk about the evolvement of this web, right? So these web-based applications, they have become they have interactive pages now, right? They have, I'm talking about testing, need of API testing. Why we need to test it? Because we have different architectures now. We have microservices architecture, right? We have a interactive pages that requires a lot of server side code migrated to the front end side, right? So whatever code that is implemented at the back end is now migrated to the front end. That is the client application. That is the browser that runs the code. So the code that used to run at the back end is now running at the front end because of this services, you can say. Or I would say because of these technology shift also, right? So if you have an application that is built in Angular, whereas JavaScript is used or TypeScript is used, all the calls, whatever you're doing on the application is only interacting with the front end. No call is going at the back end, and that is literally happening, right? It's not you can see single page applications. So the reuse and the optimization is required, for which proper structuring of the code is necessary. And there we need frameworks. There are frameworks like Angular JS, we have React JS, we have more frameworks, VU and Ember, that actually organizes the front end code JavaScript, right? They organizes it. So regarding test automation, if we talk about, because of this technology change, it will be complex to automate these front end interactive behaviors of the applications, because these changes and variations are due to a number of factors, like the make and version of the web browser, then the GUI tools, right? They won't identify these variations easily. On the other hand, these interactive web applications use web service architecture, which means most of the business logic is in the microservices under the UI layer of, or before it becomes available on the front end, and it needs testers to be more proficient in programming and API tools. So we need to test API. And let me tell you, this is one of the top trending technologies in the QA world. And we need to make sure that it's not only UI automation or UI testing, because testing at an API or at a web service level is far cost effective, or I would say fast. We have many advantages of it. So and I'm not saying only it is specific to Angular, right? It can be related to visual layout changes based on the platform or the screen size and etc. So Angular applications are, as I mentioned, they're literally single page applications, and they have the ability to react to the user's actions without reloading the pages. So you can think of when you all might have gone to a website where you start writing or you start filling a web page, right? You're filling a form on a web page, and you will notice a progression bar at the top, right? So you are not you're not firing any event from the web page. You're simply writing a text in the text box, and you're moving to the next text field, then you're moving to the next text field. But what is happening at that progress bar? It is increasing as per you are entering the data on the form. The moment you complete the form, the that particular bar is complete. So how that is happening? That is the reactive nature of or the ability of the web page that is implemented in a way using whatever technology or script, JavaScript or whatever, that without making calls at the back end, it is actually executing the code. So the testing of this becomes a little difficult, right? Because there are asynchronous calls, right? And there are sync issues in user actions. So when you automate it, it will be a little difficult, right? There can be UI changes, right? And the identification of the UI elements will be difficult. So there are some challenges here. So, and also, as I mentioned, the business layer like API layer or the REST web service function, it becomes available the moment it is available to the tester can start testing it. So testing early in web services is also possible. And we have tools for this, like we have various tools. Cypress tool we have. Earlier there was a tool called Protector, but it is going obsolete. It's a Google tool who introduced Angular. But coming back to the topic, which is web services, We have a microservice architecture, heavy utilization is there of the services, right? We also need to perform performance testing here. Test coverage can be done, faster release cycle, and cost effectiveness. So test automation, what does it need? Test automation needs a robust framework. It needs a framework that is able to create a client, send a request to the, that is basic actually, send a request to the endpoint URL and get the response. But when you send the request, it should have a payload, right? We call a payload. Payload has a data. So we should have a mechanism in the framework that uh, has a easy data creation process, right? There should be a high reusability in the framework. It's not like you're creating and there are a lot of redundant scripts in the framework. The parsing methods for the XML and JSON should be robust enough, right? And the solution should be user friendly, because it's not only you are okay, we have only 6 minutes. I'll try to finish it as soon as I can. So it should be user friendly, and it should have a better reporting, because once we get the reports, once we get the response, it has lot many tags that needs to be verified, that needs to be tested thoroughly, right? So we should have a robust test automation framework. What are its benefits in testing this? It's not like UI. When you create UI scripts, you have to write a lot of code to interact with the UI elements. When I say UI, the graphical user interface. But in terms of headless applications, which are web services, you do not need to write a lot of code, right? You do not have to create object repositories and like that. You just need to write the code. So I mean, you just need to make a call to the endpoint URL and fetch the response and validate it. Easy testing benefits of it. There's if you're testing the business logic if you're testing the web services, and not, I mean, you are testing the web services, so they are available to you first. So that is easing your testing, right? It is faster, a lot faster. So it's a simple call. So it's not like navigation to the UI. Your navigation to your script is navigating to 10 screens and then giving you the result. It's a straight call to the web service and a straight validation of the response. Low cost, you can detect the bugs early, and you're testing the business logic directly here, right? And it helps in early testing before the UI develops. Even the UI is developed by the the developer, but the tester, if the web services are available before, you can test it early. There are many tools available in the market. So we have like Tricent Test, we have Soap UI, which is an which is a free tool. We have Cathlon. Rest Assured is for RESTful services. We have Swagger, we have JMeter. JMeter is a performance tool as well. It's a web services tool as well. You can test it. You have Postman is another tool that you can use to test the services, right? So it actually helps in the improved test coverage, your web service testing. It allows automation in test cases, which improves overall test coverage and the performance of the application also, right? And obviously it is faster. So you can release the software faster. You can QA can give a sign off early on, at least on the web services testing, and it is a cost-effective solution because you're finding bugs early in if all these things are in place, agile methodology, services are available, you are finding bugs early, and uh, API testing can identify the or web service testing can identify the bugs compared to the GUI phase well in advance, right? So that is another. Let's quickly move to Codeless. All right, Codeless automation testing is nothing but it's a process of creating automated tests without writing a single line of code. So we have tools available in the market, right? So if I just go with this slide where we have testing issues, right? So time consuming. So when you write UI tests or when you're writing tests through code, it is time consuming, right? You have to create the script. They are hard, they're stiff. You need to you need to add more test cases, which is not easy, right? You need, and there can be broken builds as well. and the bugs can still escape because you are actually doing what? You are trying to implement your solution uh, in this cutting edge technologies where DevOps, CI/CD, cloud, and everything is implemented. Then you also need to raise the standards in your testing world also, right? So in the codeless test automation, you have a record and play feature. But yes, this is not what I was saying here. This is something we used to do. Earlier it was record and play, then we started creating reusable functions, then we started using frameworks, and now there is codeless automation, which is another uh, trending technologies in the software world, software testing world. What is the benefit of testing? Benefit of codeless testing is you do not have to do any setup. It is already in the tool, right? It's very easy to learn because it's a drag and drop, just click of buttons and you're creating your scripts, right? High level of reusability is there. You will get a faster feedback. There are more features in different tools. There will be seamless integration with the CI/CD tools, Jenkins or any cloud base, and the maintenance will also be low. So this is one chart that I'll try to depict where the skill sets is required. So code base, obviously you need to have a programming knowledge, but in codeless you do not have you do not need to have a codeless programming language knowledge. Maintenance is proactive in code base, but it's a self-healing capability. Test execution, configured environments, this is built in. Testing types, functional API load testing. Here in codeless you can do visual testing, compliance, accessibility, and all. So trying to cover it quickly. The last topic is cloud-based. All these are big topics, just try to cover a few of them. So cloud-based testing is cloud computing is a services they use to test the application. Its purpose is to test the functional as well as the non-functional aspects using cloud computing services. So we have many services available, that is software as a service, platform as a service, and infrastructure as a service. All have broader meaning, all have their different features. But if you look at how cloud testing is helping, you can see these, it is easily available, right? So if your solution is on the cloud, you just need a connectivity to the cloud. It's easily then and there. It's very flexible. You have many services from AWS or Google Cloud or Amazon web services. It's scalable. It saves a lot of time. Obviously, the output is really quick here, right? So you can run it over time. You can have any service, and just it is running on the cloud, and you are only bothered about the results. It is low cost. You have many available solutions on the cloud. Benefits, same, on-demand services, broader network you have resource pooling there, and you have rapid elasticity. Okay, it's the last slide. Again, copies. Yeah, cloud-based software testing that you can perform is basically user acceptance testing, system verification, security testing. You can perform disaster recovery testing. You can also test the availability testing, right? So if you want to test how much your application is available to the users, so you can easily do that on cloud, right? They have their different services and different parameters. That's a real more technical, that one needs to look into the different services and how they work. But the trending trends is in the software world is this, because many organizations are investing heavily to have their solution, their product available to their clients on the cloud, right? The multi-tenancy testing you can do, compatibility and the cross-browser testing can also be performed on cloud very easily. So these are the trending trends or trending technologies in the software world, that if you understand and have more insights on these technologies, you will generate more interest and will help you in creating more meaningful solutions for your organization, right? We are on time, right? I know I took a couple of minutes more, but any questions anyone has before I call it off for the day?
Actually, I am having a question regarding API. So can we say API and web service testing are same?
Yes, they are same, but API and web service, they have a slight difference. right? Web service, when I say it's related to web, but APIs can be developed, and different components of the same application can talk with API. But more or less, to your question, API and web services testing are similar.
Okay, and while going through, sir, agile methodology, what challenges you have faced till today?
Agile methodology. Well, yes. So as I mentioned, it's agile is quick and easy, right? That is called agile. So when anyone is coming to that environment of agility, right, might find it difficult if someone is not for the first time is doing the agile, using the agile methodology. One needs to be proactive in the team. One needs to proactively proactively raise the concerns. And if there is any blocker, for instance, I'll give you an example. If you're working on a task that is assigned to you and you have to finish that in few hours, and you're not raising your impediment well in time, then it will break the sprint, right? It will not, user will not be able to deliver that, uh, or the project manager will not be able to deliver that feature in time. So there are many, but as such, it's a very widely used technology. So once you are used to it, you'll find it interesting.
Okay, sir. And last one, please tell me if it's not getting hesitated to you. Please tell me, sir, what is the exact definition as per you as a Scrum?
Exact definition as per Scrum. So we have Scrum Masters, right? Scrum is a
Yes, but I am just want to know about the only Scrum, sir.
only Scrum. No, it's related to Agile, right? Scrum is a model in Agile. So Agile works in the same iterative way. It works in the same uh, manner, where we need to uh, be incrementally provide a workable solution, right? And how we are achieving it is through Scrum or Kanban. So Scrum is a model that a Scrum Master will will implement in the Agile meetings. So I'm not a Scrum Master, I would say, but yes, as I understand, it's a uh, uh, different way than the other word I said is Agile is Scrum and the Kanban, right? So Kanban is another model, and Scrum is another model. It's a different way of working, but Scrum Master, the roles and responsibilities are same as you follow in the Agile methodology.
Okay. So Shubham Rawat wants to know what are the most used templates for API documentation.
Most used templates. Okay. So API testing, you said?
Yes.
Right. So in API testing, see, first thing is we need to have the endpoint URL. We need to understand the WSDL, right? Once we get the endpoint, if I talk about SOAP, we get the WSDL endpoint URL. We need to understand what all methods are implemented in it and what is the structure of it, right? So in API testing, you will create the requests. So the request XMLs, if it's a SOAP, you will create a request XML, the payloads for the different test cases, right? So when you're creating the test case, you're making sure that you are providing different inputs in order to test that particular functionality, right? You will have, for example, if you have to, uh, uh, yes, another thing is the response, right? Once you get the response, you will have, you should have a proper expected results, that this is expected in the tags of the response, and maybe it a response code 200, 400, whatever, right? And you will also do some negative testing if you are, because it is developer has implemented that, but you are testing it. You need to make sure that if you're supplying a wrong data, whether it is giving you the correct results, it is breaking, or is it fetching the uh, undesirable data from the database. So it has a testing process for web services, and in terms of automation of web services, you need to identify the tools, right? You can use SOAP UI, for instance, and see how a tool is, or a Postman. You can use how a tool is hitting the endpoint URL of a web service and fetching you the response, right? Once you get the basics of it, then you can move further that, okay, what are the different, how you can automate it, right? What are the automation tools? Like if you go to Ready API, which is a smart beer tool or any other proprietary tool, then you will get to know more features about web services automation testing.
I would just like to take one last question here, which is from Vaishnavi.
Sure.
Which framework type is mostly preferred by organizations?
Yeah, so that is a very a generic question, but yes, it's not like that this is a framework that one should go at. So in the identification of a framework, one needs to first of all identify or understand the requirements, right? As I mentioned, there are different types of frameworks: data driven, modular, linear, hybrid, right? So if you are developing a framework on your own, you need to identify that what is the I'm talking about UI automation. So what object repository mechanism you are following? Are you implementing a POM model, which is page object model? If you're implementing that, it's fine. If you're using data driven framework and you are imbibing these two as a hybrid, right? So make sure that the data is loosely coupled. Every data is loosely coupled, right? And reusability. So there are basically, some basic test automation principles that needs to be implemented. So if you keep those principles in mind, your automation framework will automatically evolve to a better condition. So it can be like, first should be highly reusable, right? There should not be a redundant code in the automation. Reusability should be high. Second is data driven framework. Data should be separated from the scripts. Third is uh, it should be scalable, right? So it should be scalable with CI/CD, with the cloud and all. You need to consider these things. And if you're implementing hyper automation, make sure you're choosing the right tools and technologies. And lastly but not least, maintainable. It's not like if something is breaking in one script, then you have to fix it in all the 100 scripts that you have created. So maintenance should be high. So if you consider these principles, you will automatically get to know what framework I need to use in my organization.
Hello, ma'am.
Yes, Rovish.
Yes, ma'am. I ask one question last only.
Which
Go
one?
ahead.
Please say.
We can continue with software testing as a long-term career.
Yes, why not? I've given you enough reasons in the beginning that software testing, and it's not going to go anywhere. It's only going to grow more, right? A lot of code has been written and more technologies are coming in. And when I started my career, these trends were not there, right? But now, as I just depicted these few, there's a lot of learning, and I know in future also there will be a lot more coming in, right? So
Okay,
testing is
thanks, sir.
definitely a good career.
Okay.
Thank you. Thank you for your time.
We're
Thank
glad
you,
to have
everyone.
you.